Hi everyone, thank you for tuning in. Judy here. If you're interested in fascinating discoveries in the world of science, you've come to the right place. And if you like the content that I share, please subscribe to this channel. It won't cost you anything, and your support means a lot. Okay, my friends, before we dive into the next topic, please allow me to thank the friends who bought me coffee from my website last week. Thank you so much for your kind support, my friends. Thank you. My friends, if you're not new to this channel, you don't know that I've talked many topics about Alzheimer's disease AD and Parkinson's disease PD and some potential ways to stop the diseases, right? If you don't recall, or if you're a new friend, please check them out in the description or comments. Yeah, today I'm gonna talk about AD and PD and some new potential treatments. You see, my friends, Alzheimer's and Parkinson's are common neurodegenerative diseases characterized by the progressive loss of synapses and neurons, leading to cognitive and motor decline. Increasing evidence suggests that AD and PD share monoamine and alpha-synuclein dysfunctions, often beginning years before clinical manifestations onset. Yeah, according to some studies, Parkinson's and Alzheimer's are two different aspects of the same disease, but the triggers for the impairments and causes leading the early neurodegenerative processes to become AD or PD remain unclear. To date, there's no cure for AD, and there's no disease-modifying treatments that will slow down PD progression. But there's great news. Scientists David Joseph discovered a common master switch that could potentially cure both AD and PD and other brain-related diseases with a single method, despite the unique characteristics of each disease. Yes, his new theory proposes that one molecular master switch controls the progression of several major neurodegenerative diseases. His study explains how oxidative stress leads to the deamidation of the 4-EBP2 protein in axons, a process now links directly to cognitive decline. It means that by regulating the rate of axon-based 4-EBP2 protein deamidation may control the progression of some neurodegenerative diseases. Moreover, a team of Harvard School of Public Health scientists found a molecular switch that can turn off some cellular processes that are protective against aging and metabolic diseases. Using genetically altered mouse models, the researchers found that aged cells accumulate more SMART, a protein that the researchers focused on its role in the aging process. And they found that SMART acts like a switch, turning off the protective cellular activities of some proteins known as TARS. And the good news is there are drugs turn the protective activities of past back on. What's more, another research team at the University of Barcelona Institute of Neuroscience has also discovered new molecular mechanisms related to the cognitive decline associated with Alzheimer's disease. They found that normalization of RTP801 expression could help to restore brain network connectivity similar to that of healthy individuals. These three new potential treatments for Alzheimer's disease. Fascinating, right? Okay, my friends, in case you don't know me yet, I'm Judy Faye London, a fan of Jack London. I'm a published writer who writes fiction and non-fiction novels and short stories. You're very welcome to visit my website judyfaylondon.com or Amazon to read my poems and my short stories. The last one, Mr. Rat, Candy the Dog, and so on, and my latest non-fiction book, Living with a Walking Dead, a roadmap for achieving your own success. I hope to see you there, and thank you so much for your kind support, and thank you very much for subscribing to my YouTube channels. Judy Faye London and Judy Plus. Judy Faye London is a channel that mainly talks about culture, economics, and dictators and various events and people in human history, while Judy Plus is a channel that talks about interesting discoveries in the world of science. And my friends, if you're interested in knowing the details about this topic, please check the related articles in the description.